Section 8.1 is relations and functions. I can use graphs to represent relations and functions. The table on the top of page 385 shows the ages and sizes of 5 alligators. We can represent the relationship between age and length using ordered pairs, x and then y. So here x is 2, y is 32. X is 4, y is 59. X is 5, y is 65. X is 5, y is 69. X is 7, y is 96. The ordered pairs form a relation. A relation is a pairing of numbers in one set called the domain with numbers in another set called the range. Each number in the domain is an input. Each number in the range is an output. For a relation represented by ordered pairs, the inputs are the x-coordinates and the outputs are the y-coordinates. So here, if we have an ordered pair like 2, 4, okay, the 2 is my x value, the 4 is my y value. The 2 is also my input, and the 4 is my output. And the 2 is also my domain, and the 4 is also my range. So x and y are alphabetical, but so are input, output, and domain and range. So that's one way to help remember which part is which in our ordered pair. In example 1, we are going to identify the domain and range of the alligator information on page 385. I'm going to do domain in red and range in white. So my domain are my inputs, like 2, 4, 5, 5, and 7. My range are my outputs, 32, 59, 65, 69, and 96. So my domain, I list those values, and I put them in curly brackets to show that it's a set. 2, 4, 5, and I only list it once, even though it's there twice, and 7. And my range, again, inside curly brackets, I think they're called braces, to show that it's a set of numbers. 32, 59, 65, 69, and 96. And again, I list each of those numbers individually unless they double up like the 5s here. Then I only listed it once. We're going to identify the domain and range of the relation represented by the table below, which shows one alligator's length at different ages. So here, domain are our x's, or our inputs, and range are our y's, or our outputs. So there we just list them out. And nothing doubles up, so we're good to go. Now, feel free to pause here and give these a try if you'd like. Domain are x's, 0, 2, 3, and 5. And range are our y's, 1, 4, 7, and 4, but we already have 4, so we just close off our set there. Same idea in 2, feel free to give this a try if you'd like. Here, my range are my y's, 2, -1, 0, 4, and my domain are still my x's, -1, -3, 6, and -1, but we already have -1. So we only list it once. And again, they go inside curly brackets. They don't have to be perfect curly brackets, guys, but they can't go in parentheses because parentheses show ordered pairs. We want sets here. In addition to using ordered pairs or a table to represent a relation, we can also use a graph or a mapping diagram. So we're going to represent the relation as a graph here. I'm going to take each one of these points and plot them. Remember, our points are x and then y, x and then y. So I'm going to go where my x is -1 and my y is 1. And where these two lines meet, that is my point. My x is 2 here. My y is 0. So where they meet is here. X is 3. Y is 1. And where they meet is my point. X is 2 here. Y is 2 here. Where they meet is my point. X is 4. Y is 5. Where they meet is my point. So there I represented it as a graph. Now I'm going to represent it as a mapping diagram. And a mapping diagram I'm going to do up here just because I can see my values then. So with a mapping diagram, we're going to draw two ovals. I'm going to label them domain and range. I'm going to then fill my values. Domain, 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 already in my domain, and domain. Range, range, already in my range, range, range. My last step is I'm going to draw arrows to show inputs to outputs. So for every ordered pair, here I'm going to start at -1 and I go to 1, and we need these arrows here to show direction. I start at 2, I go to 0. I start at 3, I go to 1, and it's okay that there's already an arrow there. That's fine. I start at 3, same thing. It's okay that we already started an arrow there. We're just putting in all of our points. We go to 2, I start at 4, and I go to 5. And this entire thing here is my mapping diagram. A relation is a function if for each input there is exactly one output. Okay, so for every input, there can only be one output. It doesn't matter if our outputs double up, but each input, so every x, can only have one y. In this case, the output is a function of the input. So we're going to tell whether the relation is a function. Here, we're going to look at our inputs. 2 goes to 32. 4 goes to 59. 5 goes to 65, and 5 goes to 69. So because right here, 5 goes to 65 and 5 goes to 69, it is not a function. Every input can have exactly one output. So here we have 65 and 69, two different values, so it's not a function. In B, I have 1 goes to 23, 2 goes to 36, 3 goes to 47, 4 goes to 61, 5 goes to 73. Every input goes to exactly one output. So yes, this is a function. Feel free to pause here and give this a try if you'd like. We're going to represent the relation as a graph and as a mapping diagram. Then tell whether the relation is a function. So here, x is 0, y is 3, and where they meet is my point. X is 1, y is 2. X is 1, y is 2, where they meet is right here. X is 2, y is -1. X is 2, y is -1, where they meet is my point. X is 4, y is 4. X is 4, y is 4, where they meet is my point. X is 5, y is 4, where they meet is my point. So there I have it represented as a graph. As a mapping diagram, we two circles, label them domain and range. I list out my values 0, 1, 2, 4, 5 for domain. Range 3, 2, -1, 4 is listed twice, but I only put it in my range once. Our last step is we draw our arrows, 0 to -3. And again, we have to have that arrow to show direction. 1 to 2. 2 to -1. 4 to 4. And 5 to 4. Is this a function? Yeah. Every input has its own output. We can see that here, 0 to 3, okay? None of our x's duplicate in our ordered pairs. On our graph, none of them duplicate. And in our domain, none of them start from the same spot. So we don't have two arrows coming from the same value. Same idea here. X is -2, y is -1. X is 0, y is 2. X is 2, y is 3. X is -2, y is -4. So we have our points there. Mapping diagram, domain, range, -2, 0, 2, -2 I already have, -1, 2, 3, -4. -2 goes to -1, 0 goes to 2, 2 goes to 3, and -2 goes to -4. Now we need to determine, is this a function? No. Here, -2 goes to 1 and -2 goes to -4. Here I can see, and here I can see. Because this has two arrows, it means it's going to two different values. So it is not a function. When a relation is represented by a graph, we can use the vertical line test to tell whether the relation is a function. The vertical line test says that if we can find a vertical line passing through more than one point on the graph, then the relation is not a function. Otherwise, it is a function. So in example 4, we're going to use the vertical line test to determine whether the data represents a function. Here, I have a vertical line. And I'm going to swing it through my graph. And if I hit more than one point at a time, it fails my vertical line test and is not a function. But as I slid through there, I only ever hit 1 point at a time, which means yes, this is a function. No input gave me more than one output. Same idea here. I slide my vertical line through, but I stop here because here my vertical line hits 2 points at the same time, which means my one input 3 outputs two different values, 1 and -2. So this is not a function. So again, with our vertical line test, if we only ever hit 1 point at a time, it is a function. But anytime that we hit 2, it means for one input, we have two different outputs, and it is not a function. And that's all I have for section 8.1.